Okay, so let's start with lecture number 17. And today's topic will be, last time we have said that we'll start with AC circuits with R, L and C individually. So let's start with that. AC circuits with R only. Okay, it is also called as a resistive circuit. Now you have to be very patient and careful in listening this, because we will be discussing R, L and C individual, then combination, and then RC, RL, and then RLC. So there's can be a lot of confusion. So pay extra attention. Alright. Now please pay a complete attention over here. So you have a AC circuit. You know how this AC circuit is represented by? Vm sine omega t, right? And you apply this AC circuit to a resistor. Alright. So this is my AC voltage. And whenever there is a AC voltage, there will be a AC current flowing, right? Represented by small I. And its formula will be Im sin omega t. And this is my resistor R. Let's say voltage across this resistor is VR. Okay? So here remember R is my pure resistor. And its unit is ohms. Now, let's start with point-wise form. So first of all, I apply AC voltage represented by V is equal to Vm sin omega t. So if you all are writing, write along with me. Let's call this equation number A. Okay? Because I might not give you time to write. So write along. So this voltage gives me AC current, I. And by Ohm's law, what is I given by? V by R, correct? So it will be Vm sin omega t divided by R. Let's call this equation number 1. Alright. And what do we know about I? I is also given by Im sin omega t. Correct? Let's call this equation number 2. So if I compare 1 and 2, what is Im? If I compare 1 and 2 equation, what is Im? Vm by R. Got it? Let's call it equation number 3. So can you tell me at value of I will be maximum when? So value of current I will be maximum. Can you tell me when it will be maximum? When sin omega t is equal to 1. Maximum value is Im, right? So when sin omega t is equal to 1, the value of I will be maximum. So can you tell me from this equation number 1 and 2, are my current and voltage in phase with each other? Yeah, they are in phase. We have seen the phase equation, right? So we can write it down from equation 1 and 2, applied voltage V and circuit current I are in phase with each other. That's an important point to note. How do we know they are in phase? Because the phase difference between them individually is also 0 and they are almost the same. They are in phase with each other. Okay. So therefore, whenever AC current and AC voltage in a circuit are in phase, that circuit is resistive in nature. So write down, therefore, nature of the circuit is resistive. Resistive means V and I are in phase. That means phase difference between them is 0. Now, if I want to plot these waveforms, how will I plot? So I want to plot omega t versus this waveform. So let's say this is my sinusoidal waveform. Okay, how will be my current waveform? This is V. Same but lesser magnitude. Why? Because it is Vm by R. So whatever Vm is divided by R. Are you getting it? So it will be slightly lesser in magnitude but in phase with each other. Okay, so this is my I equation. So we can say I and V are in phase. This is pi, 2 pi, 3 pi. Now how will be my phasor diagram? This is actually x-axis. This is my phasor. How will the phasor look like? So if this is V, this is vector V, where will be I? In the same direction but lesser magnitude. Okay, why lesser magnitude? Because it is Im is Vm by R. So here we can say that the phase angle pi is 0. So whenever phase angle is 0, that means the AC voltage and current have 0 phase difference between them. Okay, this is point number 6. So write down point number 6. What will be the power factor of the circuit? Well, power factor I will explain. Power factor is given by cos phi and phi is 0. So what will be power factor of the circuit? Power factor of the circuit is cos phi. And what is phi for this circuit? 0. So what is the power factor of the circuit? 1. Now, opposition, listen carefully, opposition offered by the circuit element to the DC current flow is called as, yes, resistance. Now listen, opposition offered by the circuit element to AC current is called as impedance. Okay, so write down this important new term, impedance, point number 7, I guess. So opposition offered by circuit elements like resistor, capacitor to the AC current flow is called impedance. In a DC current flow is called as resistance, here it is called as impedance and is represented by capital Z. So it's a new term which you should remember. Opposition to the current flow in AC circuit is called as impedance. So by Ohm's law we know V by I in AC circuit is written by Z. Remember this now. This will be the new version of Ohm's law. This is equation number 4. Okay. In case of AC circuits, never call it resistance, call it impedance. V by I will be Z. Remember that. So now let's dissect it further. Please write along with me. So in a resistive circuit, what is Im given by? Vm by R, right? Correct? So we can say Vm upon Im is R. Yes or no? Now see, so that means if I divide and multiply by, I will divide both numerator and denominator by root 2, Vm by root 2 upon Im by root 2 is equal to R. Now what is Vrms and Irms? So what is this? Actually, this is Vrms upon Irms, which is V upon I is R. So if I compare equation number 4, V upon I is Z. And if I compare equation number 5, V upon I is R. That means in a pure resistive circuit, Z is equal to R. Got it? That is only possible in a pure resistive circuit. Impedance is equal to resistance. Just remember that. So please note it down. I hope you are following this. Yeah? So if you have any query, please ask immediately. I'll stop and explain that. Got the idea? In a resistive circuit, Z is equal to R. Achha, next two terms are only for information. If they ask, well and good. But this is for your knowledge, what I am doing. So this is not directly there in the syllabus, but you should know this. What will be power? Now that I am writing in blue in color. So point number 10. We are written up till here? Okay. So what will be power? Instantaneous power. What it will be? It will be V into I. And what is V? Vm sin omega t. What is I? I am sin omega t. So what it will become? Vm I am sin square omega t. Power. Sin square omega t, can I write it as 1 minus cos 2 omega t divided by 2? Got it? And I can separate out this power. So power will be Vm Im by 2 minus Vm Im cos 2 omega t by 2. This is called as instantaneous power. So as you can see, it has a DC component as well as a AC component in it. So this is my instantaneous power. Remember, what is instantaneous power? At every time instant, we can calculate this power. Why? Because we have cos of 2 omega t. Now, you've written it? Okay. So this is instantaneous power. What will be average power? So average power is important. Average power P will be V into I. Huh? Yeah, Yango. Is equal to V into I, where V is what? RMS value of applied voltage. And what is I? RMS value of circuit current. How can we write this further as? Got it? Vm Im by 2. Understood? So this is the entire summary of what happens when an AC voltage is applied to a resistive network. So we have impedance, which is equal to resistance. Current and voltage are in phase. Instantaneous power is given by that expression, and average power is V into I, which is IRMS into VRMS. So let's solve a numerical on it and cement this concept. Okay, so write down numerical number 1. You have written this much? Okay. So write down numerical number 1. The statement is an AC circuit consists of a pure resistance of 10 ohm is connected across an AC supply of 230 volts 50 hertz. Calculate A, current, B, power consumed, C, power factor, D, write down the equation for current and voltage. Okay. So an AC circuit consisting of pure resistance is connected across an AC supply. We need to find the current, power consumed, power factor, and equation of current, equation for the current and the voltage. So let's start solving. So let's first write down the given data. What is given? R is 10 ohms. What else is given? V, which is VRMS. See, whenever 230 volts is written, that is RMS value. That is not peak value. Okay. So VRMS is how much? 230 volts, and frequency is how much? 50 hertz. So tell me, what is current? Current will be V by R, right? Because in a resistive network, Z is equal to R. So what it will be? 230 by 10, 23 amperes. Now tell me, this 23 amperes is IRMS, right? This is IRMS. Next, we need to find a power consumed. Power consumed will be average power. So that will be V into I. 230 into 23. How much is that? 5290. Please check the value. Yeah. Next is power factor. Very difficult. What is the power factor of a resistive network? 1. So, but you still need to write. So, power factor is written as small pf is given by cos phi, and we know cos phi is 0. So, cos 0 is 1. So, what you will write the reason, since phi is 0 in a resistive circuit. Okay. Now, what are the expressions? We need to write the expression of I and V. What are the expressions given by? Tell me. So, V is equal to Vm sine omega t, and I is equal to Im sine omega t. So, we need to write in this form. So, first of all, we need to calculate Vm and Im, right? So, what is Vm? Root 2 times Vrms. And what is Im? Root 2 times IRMS. Now, Vrms is how much? 230. And how much is IRMS? 23. So calculate this. This will be 325.27, right? One of you please check. And this will be, how much is this Im? Vm is correct. Im is how much? 2.53. Okay. Please check these values. Now, what else we require? We require omega. So what is omega? 2 pi f. That is 2 pi into 50. That will be 100 pi. 100 into 3.14. 314.16 radians per second. Okay? Yeah. 32.53, right? Because it will be one digit less over here. Okay. Now, what will be the expression for V now? V will be Vm sine omega t. So it will be 325.27 sine 314.16 t. And I will be Im sine omega t. So it will be 32.53 sine 314.16 t. So these are my expressions for V and I. Straightforward. I mean, it's nothing new. We have done the analysis, so it's quite simple. Okay. So this is all about when we apply to a pure resistor. Now similarly, we'll see what happens when we apply to AC circuit or a AC voltage to a pure inductor and a pure capacitor individually. And then we'll move on to RC and RL and then slowly RLC. Fine? Everyone completed and got all the answers? Okay. Now write down AC circuits, AC circuit with pure inductance. Why I'm writing pure inductance? Because a practical inductor has a small resistance also. So, but this is a pure inductive. So, pure inductive circuit. Okay. AC circuit with pure inductance. So, we'll apply similar analysis. Let's start. So, you have a AC voltage given by V. We know what is V, right? And it is applied to an inductor. Inductor symbol is this way. Don't make a spring. It's L and the voltage across the inductor is VL. Current flowing through the circuit will be AC current. This V is Vm sine omega t and this is my inductor. Got it? What is small v up AC applied voltage and what is small I circuit current? So what is V given by? Vm sine omega t. Let's go through step by step. This is equation number A. So due to V, current I flows through inductor L. So whenever current flows to an inductor, it sets up a magnetic field around it. Yes or no? So the changing flux links with the coil and a self-induced EMF is self-induced EMF is induced in it and it is given by E is equal to L di by dt. Okay. So I'm not making, you can write it down. This AC current sets up an AC alternating magnetic field around L. And due to that, what happens? Flux links the coil. Actually, inductor is nothing but a coil only. And when it happens, your EMF is induced. And this induced EMF is given by E is equal to L di by dt. Got it? We call it equation number 3. I mean, this EMF E opposes the applied voltage V. So we can write this EMF E opposes the applied voltage V. So what will be it? What will be V given by then? L di by dt. Actually, E is minus L di by dt or plus L di by dt? Minus L, na? So here it is minus, so this opposes means that will be plus. Got it? E is minus L di by dt, so V will be opposes, right? So it will be plus. So this is important. Now, I'll just cross multiply. So L di is equal to V into dt. So di will be, I'm right, opening the V is sine omega t, and this L will come down, dt. Now, how will I solve this further? Di is derivative, huh? It's not a notation, it's a derivative. So how will I remove derivative? By integrating both the sides. So I'll apply integral. So that is, so I will be what you know, Vm upon L is a constant. Integral of sine omega t dt. So we have integrated LHS and RHS, the right hand side and left hand side. Now, what is I given by Vm? So what is integral of cos omega t? Sorry, sine omega t minus cos omega t. So minus cos omega t upon omega L. Got it? So what will be I given by? Can I write minus cos theta as sine theta minus pi by 2? So I'll write it in the same fashion. That is I is equal to Vm omega L sine of omega t minus pi by 2. Why do we convert into sine? Because we want to compare with the standard form. So this is my expression. Understood how we got it? This is expression number B. Understood? So please note it down. Vm upon omega L sine omega t minus pi by 2. Now, when will be this value of I maximum? When will be this value of I maximum? It will be maximum when sine omega t minus pi by 2 will be equal to 1. So write down, what is the point? 6. So value of current AC current I will be maximum when sine omega t minus pi by 2 will be equal to 1. So that means what? From equation B, what will be Im? Vm upon omega L. Call it equation number C. Im is Vm upon omega L. Okay. Now, let me write the expression of AC current and AC voltage together and let's compare it. So, point number 7. What is V given by? Vm sin omega t. And what is I given by now? I am sin omega t minus pi by 2. Now, if I compare these equations, both this both equations, if I compare, can I say my current lags behind the voltage by 90 degree? Pi by 2 is 90 degree, correct? Or my voltage leads the current by 90 degree, whatever we can say. So write down, from this expression, it is clear that your current I lags behind voltage V by 90 degree. And this happens in a pure inductive circuit. So in a pure inductor, this is the major lesson. Current lags behind the voltage by 90 degree. This is the major learning. And these two equations are important. Whenever in a circuit, current lags behind the voltage, that is a pure resistive, pure inductive circuit. So write down, therefore, nature of the circuit is pure inductive. So whenever in a AC circuit, current lags behind the voltage by 90 degree, it's a pure inductive circuit. Okay, now the waveforms. How will I draw the waveforms? So let me first draw the voltage, normal sinusoidal waveform. Okay, this is pi, 2 pi, 3 pi. Where will current start from? And current magnitude and voltage magnitude will be same? No. See, Im is Vm by omega L, so it will be lesser. Where it will start from? It lags behind. मतलब पीछे है वो. मतलब it will start from pi by 2. Okay, so as if it is an entire waveform is shifted this side. So the new coordinates will be this. Correct? So sorry. So it lags behind the voltage by 90 degree all the way go. Okay, so this is my current, and this red color waveform is my voltage, applied voltage V, and my x-axis is theta equal to omega t. Got it? Where is my phase angle? Where can I show my phase angle? Here is my phase angle, here, this one. And this phase angle is how much? Pi by 2. So these are the current and voltage waveforms in a inductive circuit. So please draw them. Understood? Remember, in an inductor, current lags behind the voltage by 90 degree, all the way go. Now, since we have drawn the voltage and current waveform with respect to time or omega t, now we have to draw the phasor. Tell me how will be the phasor. This is x-axis. So if I represent voltage here, where will be the current, up or down? If I draw it up, that means it leads the voltage. If I draw it down, that means it lags, right? So this is my voltage V and current. So this is my current and this is my voltage. And what is the phase difference between them? What is the phase difference between them? Here, phi is pi by 2 or 90 degree. So this is my phasor. If you ever wonder what is x-axis, x-axis is my omega t, basically theta. Got it? So we can say the phase angle phi is equal to 90 degree or pi by 2. Got it? Are you following? Okay, now point number 9. Okay. Write down opposition to the AC current. What it is called as Z. So let's find out what is Z for this circuit. Z for a pure resistive circuit is R. Now let's find out how much is for this inductive circuit. So what is Im given by? Vm upon omega L. So what will be Vm upon Im? Omega L. Got it? Now if I divide and multiply, both divide both numerator and denominator by root 2, what will I get? Vm by root 2 divided by Im by root 2, and that is equal to omega L. Meaning what? What is Vm by root 2 and Im by root 2? Vrms and Irms. That will be V upon I. So V upon I is omega L. And what is V upon I in AC circuit called as? Impedance. V upon I is called as impedance, Z. So if I compare these two, these two, what will be Z? Omega L ohms. Impedance, right? It's omega L. Z is equal to omega L. So that means opposition offered by inductance to the AC current is omega L. And omega L is called as, anyone knows what is omega L called as? Yes, inductive reactance. So we'll write omega L is called as inductive reactance, XL. It's given by XL. So that means it's a new term, please remember, new notation, XL is given by omega L, ohms. And if I expand omega, what XL is given by? 2 pi FL. Got it? So if it is a pure inductive circuit, my impedance will be equal to inductive reactance, which is equal to omega L. So write down a statement over here. The opposition offered by reactive elements. Which are the reactive elements? L and C, right? Reactive elements to current flow is called reactance, and it is given by X. So if the opposition offered by the reactive element, which is an inductor, it will be inductive reactance. If it by the capacitor, it is called as capacitive reactance, XC or XL. In this case, it is XL. So what will be XL now? How will you define XL? XL is the opposition offered by inductor to the AC current. Got it? Now let's find out the power. It is extra little bit, but this is important for your knowledge. First, we'll find out the instantaneous power and then average power. You have written it? You all are following? Okay. We'll understand more clearly when we solve numericals. So which point is this? 11, 12. Let's find out the power, instantaneous power. Let me save this document first. Yeah. So instantaneous power P is given by V into I. What is V? Vm sin omega t. Let me expand it further. Into Im sin omega t minus pi by 2. Okay. Sin omega t minus pi by 2 can be written as minus cos omega t. Yes, no? Okay, so P will be equal to minus Vm Im sin omega t cos omega t. What is sin omega t cos omega t written as? Sin 2 omega t by 2. Correct? And this is the expression. So this is my instantaneous power expression. Got it? Hello? Yeah? Acha, how to find the average power here? So if this is 13, how will you find the average power? You find the average power over one cycle. So P will be 1 upon 2 pi integral 0 to 2 pi. What will be it? V into I d omega t, right? Let's say it will be minus yeah this only na V into I is this only, right? So minus 1 upon 2 pi. This is na V into I, this is V into I, right? So this will be 1 upon 2 pi integral 0 to 2 pi. Don't worry, we are not going to solve this right now. D omega t. So if you solve this, you will get power as 0. It's a very, very important thing. Power, if you solve this further, power you will get it as 0. That means power absorbed in a pure inductor is 0. Okay? Power absorbed in a pure resistor is V into I, but power absorbed in a pure inductor will be 0. So write down this learning. That is power absorbed in a pure inductor, average power is 0. Instantaneous power is there, but average power is not there. Okay? So similarly, we'll solve a numerical on inductor with a AC's current with an inductor, and then we'll go to the next part. Understanding? So if you solve this further, you can solve this and find out mathematically the power will be 0. Average power absorbed in a pure inductor is 0. Now, write down the numerical. Please write down the statement. Everyone, don't lose focus in numerical. So, 10 millihenry inductor has a current of I equal to phi cos 2000 t amperes. Obtain voltage VL across it. Find voltage VL across it. VL is what? Voltage across the inductor, right? So basically this is the situation. We have a AC voltage applied to the inductor and the current flowing from the inductor is I. We need to find the voltage across the inductor. This is V. So what is given to us? L is 10 millihenry I is phi cos. Yeah, those who have just now entered, please don't disturb the class. Okay. Now, is this the standard form? No, right? Standard form is sine omega t. So how will you convert cos to sine? How will you convert cos to sine? I is equal to phi cos 5000 t. Can be written as I is equal to sine 2000 or 5000? 2000. Sine 2000 t plus pi by 2, right? Cos theta will be sine theta plus pi by 2. Okay? Now this is in the form I am sine omega t plus pi. Now please calculate Im. Im will be 5 amperes. What is omega? If I compare 2000 radians per second. And what is pi? Pi by 2 or 90 degrees. Now, what is VL actually? VL for an inductor. Just now we have done the analysis. VL is omega. No, VL is how what? See, AC voltage is given by current into resistance, right? But here it will be current into impedance. Here it will be reactance. That means it will VL will be I into XL. हम लोग I into Z लिखते हो ना, and Z is for a pure inductor it is omega XL. So we need to find XL. For that we require omega. So also XL. So please calculate XL omega L. So that will be 2000 into L is 10 milliohm. So 10 into 10 is to minus 3. So this will be 20 ohm. Got it? Now what is VL given by? I into XL. So what is I given by? I will be anyone. I will be IRMS, right? So what will be RMS? IM by root 2, right? So I is IM by root 2 and XL is 20. So please calculate this. 5 by root 2 into 20. How much is this? 70.7. Yes or no? Okay. So with this numerical, we end the discussion of today's lecture.